Did you know that when you scroll a web page, events can trigger up to 100 times per second? And this can literally crash your user's browser. Today, I'll show you how to solve this with an incredibly important technique called throttle. Before diving into throttle, let me demonstrate the problem we commonly face. Watch what happens when I scroll this web page. See that? Just a little scroll, and the console is already spammed with hundreds of lines. Imagine if this event handler makes API calls, complex DOM updates, or heavy calculations. The result is browser lag and stuttering, CPU spikes, poor user experience, fast battery drain on mobile. This is exactly when throttle appears like a superhero. Throttle means control the flow. Imagine throttle as a smart water faucet. Without throttle, water flows uncontrolled, flooding everywhere. With throttle, the faucet only allows water at a fixed rate, no matter how hard you turn it. Similarly, throttle ensures a function runs at most x times in y duration, regardless of how many times the event fires. Let me show you this visually. Here's what happens when events fire rapidly. See the difference? Normal functions fire with every event, but throttled functions maintain a steady, controlled pace. Now I'll code a throttle function from scratch. Don't worry, I'll explain every single line. Let me walk you through how this works. We have a timeout ID variable that acts like a gate. When someone calls our function, we check, is timeout ID null? If yes, we execute immediately and start a timer. During the delay period, any new calls are ignored because timeout ID is not null. When the timer finishes, it resets timeout ID back to null, and we're ready for the next call. When should you use throttle? Scroll events, infinite scroll, parallax effects, resize events, responsive layout updates, mouse move, drag and drop, hover effects, API calls, search suggestions, autosave, button clicks, prevent spam clicking. Many developers confuse throttle versus debounce. Throttle limits frequency and runs regularly. Debounce delays execution and only runs after silence. Think of throttle as a steady heartbeat. Debounce as waiting for someone to finish talking before responding. To wrap up, throttle is performance protection by limiting function call frequency. Easy to implement with just a few lines of code. Available in libraries like Lodash and React. An essential skill for every developer. Remember, throttle equals slow down and be steady. Have you encountered any performance issues that throttle could solve? Drop a comment below and let's discuss. By the way, did you notice that we actually used closures in both our throttle and debounce functions? Those inner functions accessing outer variables? That's closure magic. Next video, I'll dive deep into closures, one of JavaScript's most powerful and confusing concepts. Make sure to subscribe and hit the notification bell so you don't miss it.